Hello all, welcome back to the channel. So today let's see the second type of network synthesis, that is core 1 and core 2 forms. First let's see the steps and do one problem. Obtain core 1 and core 2 for z of s equal to s plus 1 into s plus 4 divided by s cube plus 7s square plus 10s. Such a fraction is given. So first thing is expand completely, that is remove these brackets off. So there is a formula x plus a into x plus b is x square plus a plus b of x plus ab. Okay, so for this numerator it becomes s square plus a plus b means 4 plus 1, 5s plus 4 divided by s cube plus 7s square plus 10s. That means in the fraction you must not have any brackets inside. Okay, so this is your z of s. Now we have to check some rules to be followed in core 1 and core 2. Okay, so these are the steps for core 1 and core 2. Let's see core 1 first. First rule is arrange the powers in descending order. That is, in the fraction for numerator as well as in denominator, you have to make sure that the terms are arranged or terms are having their powers arranged in descending order, that is starting from the biggest. So it is for this z of s, it is correct only s square, s raised to 2, s raised to 1 and s raised to 0. A simple number means s raised to 0. And in denominator, it is s raised to 3, s raised to 2, s raised to 1. So this rule is ready. I mean, that is powers must be arranged in descending order. That is done for z of s. And next is get the fraction z of s or y of s such that numerator is greater than denominator. I mean, numerator power is greater than denominator. So here let's see what is in the numerator. In numerator it is the second power and in the denominator it is the third power. But for core 1 it is written that we must have numerator power. Numerator power must be greater than denominator, isn't it? So it is just a reverse in this case. So what to do? Let us take the reciprocal in both sides. So it becomes s cube plus 7s square plus 10s divided by s square plus 5s plus 4 in the RHS side. Now when we take the reciprocal for z of s for impedance function, it becomes admittance function. Okay, so that is how you choose, that is whether you have to start from a z of s function or a y of s function. The rule is you have to get the numerator power greater than denominator. Okay, accordingly you have to choose z of s or y of s for the operation. So for this question we had the second power in the numerator and third in denominator. So we just took the reciprocal and got like numerator greater than denominator, isn't it? Here now numerator has third power and denominator has second power. So this is done and we got or we chose the function y of s. Okay, now we have to divide it. Okay, so let's start dividing this thing. So let's divide this, that is s cube plus 7s square plus 10s divided by s square plus 5s plus 4. Okay, so how we divide this means first term of this quantity, first term of this dividend divided by first term of the divisor. So s cube divided by s square is equal to s. You have to write the answer in the right side of the dividend. Okay, now multiply this answer s throughout with this divisor. So s into s square, s cube plus s into 5s, 5s square, s into 4s, 4s. Okay, now subtract it. 10s minus 4s, 6s, 7s square minus 5s square, 2s square, s cube minus s cube 0. Now next thing is you have to take this polynomial over to here. Okay, now draw the this thing and s square plus 5s plus 4. Now you have to divide this one, I mean the s square plus 5s plus 4 divided by 2s square plus 6s. Okay, so just continue doing, I mean divide the first term of this dividend divided by first term of this divisor, s square by 2s square. What is s square by 2s square? It is simply 1 by 2. So 1 by 2 is your answer. Now multiply this 1 by 2 throughout in this term. 2s square into 1 by 2 is simply s square. 1 by 2 into 6s is 3s. It's over. Now subtract it. 4 minus 0, 4. 5s minus 3s, it is 2s. Okay. So again, after getting the remainder, you draw this curve, and next is take this term over to here. Okay. So it is 2s square plus 6s. Okay. Now divide the first terms. 2s square divided by 2s. 2s square divided by 2s is simply s. So s is written. Now multiply this s with this. S into 2s is 2s square. S into 4 is 4s. Okay. Subtract it. 6s minus 4s, 2s. Next what to take? If the remainder is ready, then next step is taking this previous divisor over to here. Draw the curve. 2s plus 4. Okay. First term 2s by 2s is 1. 1 into 2s, 2s. Subtract it. 4 minus 0, 4. Now remainder is ready. So draw a curve and take the previous divisor over to here. So it is 2s. 2s divided by 4, that is 2s divided by 4 is s by 2. S by 2. S by 2 into 4 is 2s. Finally, you got the remainder as 0. So this length is the division. So, and you can see that many quotients come out from each division, isn't it? So we have to actually make use of these quotients. Like, from where did we start? We started from y of s, isn't it? We started from y of s. So the first quotient becomes y1, and the second quotient becomes z2, and the third quotient is y3. That is, alternately write y and z, y, z, y, and the next letter will be z, but continue writing the numbers 1, 2, 3 and 4, and the next quotient is y and the number is 5. So thus we have these many quotients. Actually these quotients becomes the elements for our diagram, elements for our circuit. Okay. So for that you need to study one table. I will write it now. See, this is the table you need to by heart. That is according to our quotients. That is, if our quotients is y terms or if our quotients is z terms, you have to take the element correspondingly. Okay. I will tell you how it's done. See, this is the table, and let's take the first quotient. It is y. So let's make use of this y of s table. And our first quotient y1 is equal to s, or it is 1s. Okay. So compare the pattern. That is, it is of the form as, isn't it? So it indicates the presence of a capacitor. So this actually is a capacitor. Okay. And capacitor with value A, or capacitor with value 1 farad. Okay, unit of capacitance is farad. Now the next quotient is Z. So make use of this Z of S table. And from this, let's choose the pattern. But here it's simply a number 1 by 2, isn't it? So it indicates the presence of a resistor. So it's a resistor coming there, and simply the number becomes the value, half ohms. Okay. Now y3, next quotient is y3. So take from this table, that is, here it is 1s again. So as, that means it's a capacitor of value A, or 1 farad again. And next is impedance, or Z4. Again it's simply a number, so it's a resistor with value 1 ohm. And lastly it is y5 equal to, or the fifth element is an admittance in 1 by 2 s pattern. That is, 1 by 2 s means as again. So A here is 1 by 2, isn't it? So it is a capacitor again, and value is 1 by 2 farad. Okay. Now let's collect all the elements. Let me write down. So this is the list, and we start from an admittance element, isn't it? Actually, this core form is a mix of series and parallel elements. Series and parallel elements coming alternatively. In Foster forms, we had only series combination or only parallel combination, isn't it? But in core form, it is a combination of series and parallel. Okay, either we can start from a parallel branching or we can start from a series branch. Okay, this is the format, and both represents core or core 1 or core 2. Okay, how to differentiate it means, if our first quotient was a y function or y variable, then we have to start from this section, that is parallel branching. We have to start from parallel branching. Okay, and if the quotient, our first quotient was a z function, you have to start from the series branching. Okay, so in this question we had the first letter being y. So our diagram will be of this sort. Okay, so that is, you have to start from drawing a capacitor in parallel. So it is like a capacitor in parallel, then resistor, capacitor, fourth element is resistor, and last element, fifth element is another capacitor. So all y terms becomes parallel branches and all z terms become the series branches. Okay, so here values, just copy down the values: 1 farad, half ohms, 1 farad, 1 ohm and half farad. So this is your core 1 representation. Okay, now let's do core 2. For core 2, see, this is our question, and to form core 2 diagram, we have to arrange the powers, arrange the fractions in ascending order. The powers of the numerator and denominator must be in ascending order. So z of s becomes 4 plus 5s plus s raised to 2 divided by, here also make it in ascending order, 10s plus 7s raised to 2 plus s raised to 3. Okay, so the first thing is ready, and the next thing is we have to take the fraction z of s or y of s like such that the numerator is less than denominator. That is, here the power is square. In the numerator the higher power is 2 and the denominator the higher power is 3. So which one is greater? Denominator is greater. So we can continue with z of s itself, isn't it? So divide this z of s. So here 4 plus 5s plus s square divided by 10s plus 7s square plus s cube. Procedure is just the same, 4 divided by 10s. 4 divided by 10s is 2 by 5s. 2 by 5s. Next, multiply 2 by 5s throughout here. So 2 by 5s into 10s, it is 4 plus 2 by 5s into 7s square. 2 by 5s into 7s square is 14s by 5. Yes, 14s by 5. Next, 2 by 5s into s cube. 2 by 5s into s cube. It is 2 by 5 s square, isn't it? 2 by 5 s square. Now, subtract it. S square minus 2 by 5 s square. S square minus 2 by 5 s square is 3 by 5 s square. So, next 5 minus 14 by 5. 5 minus 14 by 5 is 25 minus 14 divided by 5, 11 divided by 5. So it is 11 divided by 5s. Okay. Now take this divisor over to here. Okay. Once you arrive at a remainder, take the previous divisor to dividend place. Continue dividing. First term, 10s divided by 11 by 5s. 10s divided by 11 by 5s. It is 50 by 11. Okay. 50 by 11 into 3 by 5. 50 by 11 into 3 by 5 s square. So, 30 by 11 s square. Reduce it. S cube minus 0, s cube. 7 minus 30 by 11. 7 minus 30 by 11 is 77 minus 30 by 11. So 47 by 11. 47 by 11 s square. Now we are ready with the remainder. So take the previous divisor over to here. Continue dividing. So all the questions are ready. Now we have to start from set because the division we applied was a set of a function. So we have to start from set 1. Okay. So set 1, y2, set 3, this is your y4, and lastly here is your set 5. Okay. So let's write it as a list. Set 1 is 2 by 5s, y2 is 50 by 11, and set 3 is 121 by 235s, y4 is 50.2. Lastly, set 5 is 4 by 47s. Okay. Now let's compare this with the table. So this is the table. Now first let me draw the layout for this core 2 form. That is, we have to start from a series connection. So a series connection, a parallel one, a series one, parallel one. Since we have 5 elements, we need 5 gaps. 1, 2, 3, 4, finally 5th gap. Ready? Now compare with the set of a table. So this is of the form 2 by 5 s means a by s, isn't it? So a value is 2 by 5 here. So just take the reciprocal of 2 by 5, that is 5 by 2 is the value and it's a capacitor, 5 by 2 farad. And next is from y table, it is 50 by 11, so it's simply a number. Take the reciprocal and draw a resistor. It's a resistor of value 11 by 50 ohms. And next is a set function, that is set here is of the form a by s, isn't it? Yes. So a value is 121 by 235, but take the reciprocal and write the value for capacitor, that is 235 by 121 farad. Fourth one is from y table, it's simply a number 50.2. So have to draw a resistor with the value reciprocal of 50.2. It's about 0.0202 ohms. Fine. And lastly, it is an impedance. So A by S formats. Again, it is a capacitor with value 47 by 4 farad. So here comes set of S form, that is the core 2 form. Okay. Now let's do a question from question paper December 2018. Here, find the core 1 and core 2 forms of the RL impedance functions. Z of is equal to this one. Actually, when you observe this fraction, you can see that the highest power in the numerator is 2. Also in the denominator, the highest power is 2. So how to do such kind of problems where the powers of numerator and denominator becomes equal? Actually, we proceed by calculating or by finding out which power is greater, whether the numerators or denominators. So what to do if such a question is come where both the powers become equal? Okay, so let's do this. So for such a question, you cannot follow these 3 rules, which means you have to eliminate this last 2 rules and bring another new rule, that is this thing. So these are the current rules for you. That is, you have to get the values for poles and zeros. What these poles and zeros means? The answers, the roots of numerator is called 0 and roots of denominator is called a pole. That means the s values, roots means s values. Okay. So for numerator, for this question, in numerator, value for s is equal to -1 and s is equal to -3 for the numerator to be 0. And for denominator, values for s is -2 and -6 for the denominator to be 0, isn't it? That means -1 and -3 are called as zeros and -2 and -6 are called as poles. Okay. So after writing the zeros and poles, you have to identify which root is nearby to the origin. That is here s equal to -1, -3, -2 and -6. Which is nearer to origin? S is equal to -1. So if 0 is nearer, you have to choose y of s. If a pole was nearer to origin, then you have to choose z of s. That is for core 1. Okay. So for this question, we have the 0 nearer. So for core 1, we have to take the fraction as y of s, and for core 2, we have to take the fraction as z of s, because here it says that if the 0 is nearer, then you have to take z of s. So let's do core 1 first. That is, to do core 1, we have to divide the y of s function. Also make sure that the powers are arranged in descending order. Okay, let's do core 1 with y of s division. So this is your z of s. Let's take y of s there. S plus 2 into s plus 6 divided by 2 into s plus 1 into s plus 3. Expand it, s square plus 8s plus 12 divided by 2 into s square plus 4s plus 3. Again take 2 inside. 2s square plus 8s plus 6. Okay. Now make sure that the powers are arranged in descending order. Yes, it's in descending order, 2, 1, 0, right? So let's start dividing. So this is the complete division, and since we had y of s division, we have to start from y1 z2 let me list them out. So the first element is our admittance element. We have to start from a parallel branch, and it's just a number, so it's a resistor there. Value is 1 by a. So 1 by 1 by 2 is 2 ohm. So next is s by 2 and an impedance function. So we have to make a series connection. Since it is AS form, we have to draw an inductor there with A value half Henry. Next is admittance. A simple number is there. So it is a resistor with 7 by 8 ohms. Again impedance, that is 49 by 30 Henry. Last is just a number, a simple number, so a resistor with the reciprocal 42 by 15 ohms. So here comes your core 1 y of s, core 1. Okay. Similarly, you can try out core 2. So for that, for core 2, you need to arrange the powers in the ascending order. Also here, since the question is having numerator and denominator powers equal, we have to check for the pole. We have to check whether the pole or 0 is getting closer to the origin. So here in this case, in this problem, we have the 0 nearer to the origin, isn't it? So when 0 is nearer, you have to choose z of s. So for here, let's take the z of s itself. That is z of s equal to 2 into s plus 1 into s plus 3 divided by s plus 2 into s plus 6. Expanding, you get 2 into s square plus 4s plus 3 divided by s square plus 8s plus 12. Expand it completely. It is 2s square plus 8s plus 6 divided by s square plus 8s plus 12. continue the division, but before that arrange it in ascending order. So this is our set of s, 6 plus 8s plus 2s square divided by 12 plus 8s plus s square. Now continue dividing. So here is the complete division, and we have to start from set 1 because we divided the set of s function. So set 1, y2, set 3, y4, and lastly set 5. Okay, list it out, compare it with the table. Let's draw the layout first. Start from a series combination, then a parallel one, series 1, a parallel one. There are 5 gaps, 1, 2, 3, 4 and 5th gap. Okay, so Z is equal to simply a number, so it is a resistor there with half ohms. And next thing, it is an admittance 3 by S, so A by S, so it is an inductor there with 1 by A, 1 by 3 Henry. Third one is a number 4 by 7 ohms, and fourth one it is Y, so check from this table, it is 98 by 13 S, so A is 98 by 13, so inductor value is 13 by 98 Henry. Lastly, it is a number, so it's a resistor with value 13 by 14 ohms. So this is your set of S, and this is a representation of core 2. Okay, so that's all with this core network synthesis. And if you like the video, please do like, share and subscribe it. Till we meet in the next class, this is Minu signing off. Thank you and take care.